Hello, I'm Dr. Luiz, and today I'm gonna be presenting the work done by me and Dr. José Alfredo, which is the use of lightweight deep neural networks in low-cost hardware in order to identify invasive weed species in crops. This research emerged because of the need for food production. According with FAO, it's expected to reach 9.7 billion by 2050. Therefore, it will significantly increase the food demand. And when we talk about food production, we can focus on several crops. But if we think in cereal, we're going to be talking especially about corn and soybean. And normally the losses in these crops due to weeds is from 13 to 15% when managed. And if no management is done, losses can reach 90%. It's also a labor-intensive job and error-prone task when done by humans. Therefore, it's necessary automation, especially using AI solutions. Therefore, in this work, we use an artificial neural network application in order to identify weeds on corn and soybeans on visible spectral images in order to further this research into embedded and tractor devices. For this research, we used the 4-weed dataset from the University of Purdue. It's composed, as mentioned, from 4 weeds that are harmful for corn and soybean. On table 1, we have the distribution of images as well as number of plants per weed species. Therefore, we will be focusing these 4 weed species. On table 2 and table 3, we have the distribution of images for training and for testing, according with the 4-weed dataset. We choose the YOLOv5 neural network, and we've performed all the training on Google Colab Pro. We also set an image resolution of 640 to 640 pixels, and our architectures were trained for 150 epochs. Talking about the YOLO architecture have reached good results on the last years and have been widely used by the computer vision society. It's composed of 3 main blocks, which is the backbone, which receives the input images and process it, the pan neck, and finally the YOLO layers, which provide 3 types of feature maps for especially object detection, which was the focus of this work. After training, we performed quantization. Therefore, the original weight was based on FP32. We used the quantization for FP16 for 16 bits and also int8 for 8 bits representation. We also did weight transformation to ONNX. Therefore, we pick up the best.pt weight and convert it into ONNX. And we performed all the tests on the Raspberry Pi of 4 gigabytes of RAM. We placed some coolers and fans in order to avoid overheating of the Raspberry Pi. And an interesting point is that it can be found on an official website for the price of $35. Therefore, it's very competitive. Here we have pictures showing what is the expected and what was the achieved results. And figure 6 we have the annotations with the bounding box, and on figure 7 we have the inference results on the validation dataset for the YOLOv5X. Well, here we have the different size of weights based on conversion to ONNX and also quantization to FP16 and int8. As we can see, the YOLOv5N is the lighter model, while the YOLOv5X is the heavier that was expected, and it achieved the weight of 2 megabytes for the int8 representation. So it's a very compressed weight, and in the following slide we have the inference results. Here we have the inference results for the YOLO v5. The fastest model was the YOLO v5n with ONN-X conversion and also int8 representation. For ONN-X it reached 0.37 images per second, and for the int8 representation it achieved 0.39 images per second, so almost 3 images per second. And based on what was presented, a system was proposed in order to identify invasive species for corn and soybean using the YOLO v5 architecture. We performed several tests with different quantization and conversion methods, and all the testing were performed on the Raspberry Pi board. And as main contribution of this work is that an approach was proposed and demonstrated end-to-end in demonstrating how to deploy an artificial intelligence system with quantization and conversion applied into the identification of weed species to harmful species for soybean and corn with a low-cost hardware. Thank you for your time.